Hey everybody, it's Hazel. Welcome back to another ACE Explains video. Today I'm going to be teaching you guys how to solve systems of equations by substitution. So when you're solving a system of equation by substitution, it is basically a way that you can take one equation and substitute it for a specific variable in another equation. So when we say systems of equations, that's two or more equations that all are related to each other. They have the same x and the same y, and sometimes the same z or other variable letters, but they all have the same values for the unknown variables. So you can use one equation to solve the others, right? So with this equation that we have here, 2x plus 3y equals 23, and x equals y plus 4, we're going to be solving using the substitution method. Basically, we're going to take one equation and we're going to substitute it for a single variable. Now, not all of your questions will be this easy, but I wanted to start with one that was easy so that you can kind of catch the vision and kind of catch on to what I'm doing here. So you have 2x plus 3y equals 23, and then you have x is equal to y plus 4. Now here's the fun thing about the equal sign. When you have an equal sign, it means that whatever is on the left and whatever's on the right of the equal sign are exactly equal so that they can be substituted for one another. Basically, wherever you see x, you can replace it with y plus 4. Since x is equal to y plus 4, wherever you see x, you can replace it with y plus 4. So I see x right here in the 2x. So I'm going to replace that x with a y plus 4. So that new equation is going to be 2 times y plus 4 plus 3y equals 23. Okay, so this equation is now replaced by this equation, where instead of x, I have a y plus 4. All right, so it probably do us good to rewrite the problems. So actually let me add another page and then we'll rewrite the problem. Copy this. Okay, I think that's a good size. Okay, now, when we're solving equations like this is an algebra equation. If you're watching this, you're probably familiar with most common algebraic rules. So I'm just gonna solve this out loud and have you follow along. So I'm gonna distribute the 2 to the y and then also distribute to the 4, like so. So 2 times y is 2y plus 2 times 4, which is 8, plus 3y is equal to 23. I will then combine like terms, so my terms that have y's in them. As you can see, we're right now only working with one variable, which is the variable y. The whole point is to only have to work with one variable, so you can solve for that variable first, then come back and solve for the other variable later. Since the only variable that we're working with right now is a y, we will be solving for y, right? So we used x to substitute, but now we're solving for y. Gets a little confusing, but I promise you'll get the hang of it as you do some practice. So 2y plus 3y, we're going to put those together since they are like terms, plus 8 equals 23, right? So you want to put the like terms together. Don't try to solve with them in separate sides of the problem. Always get the like terms together on one side. So 2y plus 3y is equal to 5y, since it's like, if I have 2 y's and if I have 3 y's together, it makes, 1, 2, 3, 4, 5 y's. So you have 5y plus 8 equals 23. Now, I've put my y in red just so you can see it, but we want to get our y on one side of the equation, and we want to get our like terms, so the terms that don't have a variable attached to them, don't have a y attached to them, we want those on the other side. So I'm going to take my 8, and I'm going to get rid of it by subtracting by 8, by doing the opposite operation. I get rid of the 8, and now I just have 5y equals, I believe, 15. 23 minus 8, 15, right? Then I'm going to divide both sides by 5. This is all easy algebra stuff. Like I said, if you're watching this video, you probably know how to do this. Y is equal to 3. Okay? My hands are a little shaky because I had some coffee this morning, and so it's like hard for me to draw a stable circle. Y is equal to 3. I think that's good enough. Okay, now that we know that y is equal to 3, we are going to go back to the original questions, and we are going to plug y in so that we can find x. Now, the easiest thing to do is to plug it in to the second problem, since you don't have to do any math. With the first problem, it would be a little harder. So we know that x is equal to y plus 4. Now, if we know that y is equal to 3, we're going to take 3 and we're going to substitute it for the y, okay? So now, x is equal to 3 plus 4, which is also equal to 7. So y is 3 and x is 7, all right? So we know that y is 3, we know that x is 7. Now, we want to check our work. So I'm going to plug it into the first equation now. You want to use a separate equation from the one that you just used, because that way you don't have any error. That way you can really see if you're right. So 2 times x would be 2 times 7 plus 3 times y, which would be 3 times 3. And altogether, that should equal 23. Remember, I'm using the first equation up top. 2 times 7 is 14, and 3 times 3 is 9. Now, if you have your calculators with you, or if you can do it off head, what's 14 plus 9? 14 plus 9 is equal to 23, and that, surprisingly enough, is also equal to 23. And so I'm going to do it like this. 23 equals 23, check, just like that. You want to have the number on the left equal, number on the left, I forgot that's mirrored. You want to have the number on the left equal the number on the right, and then bing, check mark. So 23 equals 23, check. So we did this correctly. X is 7 and y is 3. Sometimes your teacher may have you represent the numbers that you solved for as an ordered pair, okay? In an ordered pair, the format is x, comma, y in parentheses, right? So what would that be for this problem? Our x is 7, our y is 3, and we embrace those two numbers in parentheses. So your teacher is able to know what you got for your x value and what you got for your y value. So that's an ordered pair right there. Okay, I'm actually surprisingly happy at how easily this was to demonstrate. Let's now do a problem where we're solving for y first. So this is kind of like the opposite. 2x plus 5y equals 19. Y equals 3x minus 3. So same deal, substitution. We know that y is equal to 3x minus 3. So that means wherever I see y, I can substitute it with the equation 3x minus 3, or the expression. Let's go with expression, because yeah, it's an expression. The expression 3x minus 3. So many math terms. You always try to figure out how to say things. So 2x plus 5 multiplied by the expression 3x minus 3 is equal to 19. All right, now we distribute the 5 like this to the 3x and also to the 3. So we get 2x plus 5 times 3, 15x, minus 5 times 3, 15, equals 19. We combine like terms, so we're going to combine the 15x and the 2x together, and that gives me 17x. Sorry, I'm trying to search for the red color here. That gives me 17x minus 15 equals 19. Now, same thing like before, we want to get the 17x alone on one side of the equal sign, and we want to get all the other numbers that don't have variables, all the other constants on the other side of the equal sign. So what are we going to do? We are going to get rid of the 15 by adding 15 to both sides. Add 15 here, and that takes it away. Add 15 here. Now 19 plus 15 is equal to 34, so we have 17x, write it over here. 17x is equal to 34. And I'm going to divide both sides by 17. X equals 2. So we know that x equals 2. So now we're going to plug 2 back into the original system of equations to see how we can solve for y. Like I did before, I'm going to use the bottom equation since it's going to be a little bit easier than using the one at the top. So I go y equals 3x minus 3. But I'm going to substitute x for 2. So y equals 3 times 2 minus 3. Y equals 6 minus 3. Y equals 3. So x equals 2 and y equals 3. To test our theory, we are going to put both of those numbers into the top equation. So it's 2x plus 5y equals 19. Let me rewrite it. 2x plus 5y equals 19. So we know x is 2, 2 times 2, plus 5 times 3, because y is 3, equals 19. 2 times 2 is 4, plus 5 times 3 is 15, is equal to 19. 4 plus 15 is 19, which is equal to 19. 19 equals 19, check. So we know that we got the right x and the right y. Let's write it as an ordered pair. X is 2, comma, y is 3. And that is our answer. Okay, we're doing so well. We're making such great progress. Now, we have another question. This time, however, it's not quite so straightforward, our x and our y. With this type of problem, we actually have the opportunity to choose whether or not we want to solve for x first or to solve for y first. Let me show you how. X plus y equals 5. If I wanted to solve for x first, I would do my best to get all the extra stuff on the other side of the equal sign. How would I get rid of that y? Well, just like a number, I would subtract y from both sides, and I would get x equals negative y plus 5, right? Just like that. But let's say that I wanted to get rid of x instead. So I need to get rid of this x right here. Move it to the other side so that it can be a y equals equation. Well, same deal. I would just subtract x from both sides, and I would get y equals negative x plus 5. So no matter which way you spin it, you will get something negative plus 5. So like I said, it's really up to you. I'm going to choose to use x. Actually, I just decided I could solve it both ways, but I don't know if I have time for that. So let's just use x for today. So we know that x is equal to y plus 5. So I'm going to substitute x in the 2x. That goes right here. I'm going to substitute that for minus y plus 5. So 2 times minus y plus 5 plus 3y is equal to 12. And I'm going to distribute the negative y and the 5. Man, my hand is shaky from the coffee. You see, like, my lines are like, oh. Okay, 2 times negative y is equal to negative 2y. And 2 times 5 is equal to 10. plus 3y equals 12. All right, let me rewrite that right here. 2y plus 10 plus 3y equals 12. Okay, negative 2y and negative 3y are like terms because they both end in a y. So I'm going to add those two like terms together. Plus 10 equals 12. Negative 2y plus 3y is 1y because it's negative 2 plus 3. Yeah, it's 1y. 1y can also just be written as y. Get it? 1y. But okay. It's like a nerdy math joke. Okay, so y plus 10 equals 12. To get y on its own, we're going to subtract 10 from both sides. And we get that y is equal to 2. 12 plus 10 equals 2. Sorry, 12 minus 10 equals 2. Y is equal to 2. We plug that into the other equation. We can actually plug it into the bottom one, just like we have been. X plus y equals 5. Substitute y for 2. X plus 2 equals 5. Think about it. What plus 2 equals 5? So x equals 3. You could also subtract by 2 from both sides, but this seems like an easy elementary school problem to do. So we know that x equals 3, and we now check our work. So we have 2 times x, 2 times 3, plus 3 times 2 equals 12. 2 times 3 is 6, plus 3 times 2 is 6, equaling 12. 6 plus 6 equals 12, which is equal to 12. 12 equals 12, check. Yay! Okay, I love when math just works. That was super off key. Now we are kind of met with a bit of a challenge. Usually we use, or throughout this entire video, we've been using the second equation. However, this time the second equation looks to be a little bit more difficult than the first equation. So we're actually gonna switch it up and we're gonna use the first equation instead. We see that this first equation is a 3x plus y problem. So in order to substitute, we need to get the y by itself on the equal sign so that we have something to substitute with. That means we need to take this entire 3x over here and move it all the way over here. How can we do that? Well, we can subtract negative 3x from both sides. And that gives us y is equal to 7 minus 3x, just like that. So now that we know y is equal to 7 minus 3x, we can substitute this for this. So 3x plus 2 times 7 minus 3x is equal to 8. I distribute the 2 to the 7 and the 2 to the negative 3x. This gives me 3x plus 14 minus 6x equals 8. 3x and negative 6x are like terms. I'm gonna just pull that part of the problem over here. So I'm gonna put them together like so. 3x minus 6x plus 14 equals 8. Combine like terms, so this is like a negative problem. So 3 minus 6 is actually saying 6 minus 3 and then put a negative on it. 3 minus 6 is equal to negative 3. So negative 3x plus 14 equals 8. Now, I want to get the negative 3x by itself on that side of the equal sign. So I am going to subtract 14 from both sides, and that gives me negative 3x equals negative 6. 8 minus 14 is negative 6. Divide negative 3 from both sides. Negative, negative crosses out. So it's 6 divided by 3, x equals 2. X equals 2. Awesome. So we know that x equals 2. We can pop x equals 2 right up here in the first equation, since that seems to be the easiest. So we've got 3 times 2 plus y equals 7. 3 times 2 is 6 plus y equals 7. So it's pretty obvious that y equals 1. I picked pretty easy numbers since this is like an introduction, getting ready to do it. Okay, I'm going to skip the checking part. Actually, I'm not going to skip the checking part because that's the most important part. So 3x plus 2y equals 8. And we know that x equals 2 and y equals 1. So 3 times 2 plus 2 times 1 equals 8. So now we're in the checking part. 3 times 2 is 6, plus 2 times 1 is 2, which is equal to 8. 6 plus 2 is 8, which is equal to 8. So 8 equals 8, check. Yay! Okay, let's try one more. This time, I'm gonna have you try this one on your own. So pause the video, try this one on your own, and then we'll come back together and check it. Okay, let's try this one together. So you see here that you have x equals 2y, x plus 2y equals 9. So we obviously know we're going to be trying to get some sort of equation where x is on one side of the equal sign and 2y goes to the other side so that you can substitute for the variable x. So I'm going to subtract 2y from both sides, and it's going to give me x equals 9 minus 2y as my new equation. I can substitute x for this x right here. So 5 times 9 minus 2y plus 2y is equal to 13. I now substitute, I forgot where I was for a second. I now substitute the 5 times 9 and then 5 times negative 2y. I'm sorry, I think I was saying substitute and that's what got me confused. I meant to say distribute, not substitute. I distribute the 5 to the 9 and then to the negative 2y. 5 times 9 is 45 minus 5 times 2y, which is 10y, plus 2y equals 13. And I found some like terms here. Negative 10y and 2y are both like terms. And they're already next to each other, so I don't have to rewrite them. But basically, you have 45 minus 10y plus 2y equals 13. 45 minus 12y is equal to 13. And now I need to get the 12y, or the negative 12y, alone. So I'm going to subtract 45 from both sides of the equation, like so. And I get negative 12y is equal to, I'm trying to think, what's 13 minus 45? 13 minus 43 is 30, is it 32? 13 minus 43 is negative 30. So minus 45 would be 30? That does not make sense because negative 12 is not divisible by 30. Hold on. I think I forgot to bring my calculator with me. 13 minus 45 is negative 32 indeed. So we're gonna have some sort of fraction or something. That was not my intention at all. Okay. Negative 12y is equal to negative 32y, and we're going to divide both sides by negative 12. As I rack my brain to figure out what went wrong. Okay. 32 divided by 12 is, it's a 2/3. So 2.6. So 2 times 2/3. 6 plus 6 plus 2. What is going on? 14/3? What is going on? 8/3. 8/3. Yeah. 32 divided by, oh my gosh, okay. Something's wrong with this problem, so we're not gonna do it. What the heck? Okay. All right, thank you guys so much for watching this video. As always, if you have any questions, make sure to leave a like down below and also subscribe so you can see more videos like this. You may have noticed that I kind of cut it off weird. Basically, we were supposed to do another problem, but something was going wrong with the math. I think I copied the problem down wrong, but basically it wasn't gonna be a divisible number, it was gonna be a decimal, and I felt like that was too advanced for this particular video, so we will cover that in a different video for sure. But as always, if you have any questions, make sure to put them down below and someone from our team will answer them, and make sure to explore all the other videos in the algebra playlist. All right, guys, see y'all next time. Bye-bye.